IP addressing. IP addressing. The Internet Protocol is what the entire information technology depends upon. Information technology uses the protocol called IP for communication. This protocol needs an address to identify the device. If that address is 32-bit size, then it is IP address version 4. If that address is 128-bit size, binary bit size, then it is IPv6. These two are two different protocol stack. They are not same header. IPv4 header and IPv6 header are totally different. But these two protocols work in network layer. Layer 3 of OSI. Network layer. That's why we call IP address as layer 3 address. That's why we call all the routers as a layer 3 device. Because the router focus only on IP address in the packet. See, in the packet you have MAC address, you have port number, you have content, you have application ID, you have user ID, you have session IDs. Routers focus on the destination IP address to decide where the packet to go. It is not focusing on port number or the MAC address, the destination MAC address. It focuses on the IP address first. It wants to know the destination IP of the packet. That's why routers are called as layer 3 device. Any device that routes the packet, it can be a firewall, it can be a multi-layer switch. If it is routing, it is going to route based on the destination IP address of the packet. All those devices are layer 3 devices. Devices that focuses on destination IP address. They are called as layer 3 device. Now, we are not going to focus on 128-bit address now. First we'll focus on 32-bit. Later, after learning routing protocols, we will have a good introduction to IPv6. Now, IPv4. It's 32-bit address size. Now, this 32-bit, just 32-bit, needs to supply the internet service, needs to support communication all over the world, across the world, continents, states, and countries. Just 32-bit. Only 32-bit to connect the whole world is a challenging one. To avoid wastage of IP address, addresses were categorized. Addresses were categorized. To use the addresses without wasting. Classified like this. Class A, B, C, and D and E. We'll talk about D and E later. This is 3 main classes, more important. Let's finish this first. Class A is the range of network that can provide millions of address. Class B, thousands of address. Class C, few hundreds of address. So those who want millions, they will go for Class A. Those who want some thousands, they will go for Class B. Those who want in hundreds, they will go for Class C. So there won't be wastage. One company needs only few hundreds. So they won't waste by taking a Class A. So to avoid wastage of IP address, classification was done. As I said, Class A will have more bits for network compared to Class B and Class C. These red lines are bits given for host. Host means devices in the network, not the network portion. Network portion is the green lines. If you see more red lines are in Class A. Totally we have 32-bit. That 32-bit is equally divided into 4 parts, which means 8-bit each. We call it as octet. Eight multiplied by 4 gives you 32. 32. You got 32-bit in which only first 8-bit for network. 24 bits are for host. But the 24 bits are not in one group, it is in 3 groups. Each group is 8-bit. So for the host, you got 3 octet in Class A. Host bits are 24 bits. Network bit 8-bit. Class B 16-bit of network, 16-bit of host. Class C 8-bit of host and 16-bit of network. Now it is a binary system. This is not 8-digit, this is 8-bit. In each octet, it is 8-bit. If we understand one 8-bit, it is the same thing for other 8 bits, right? So we will try to understand how this 8 bits are arranged and so on later. But before that, let's finish this classification story. Class A. If you will see an address beginning with a number ranging in between this range, any number in between this range, 1 to 126, that address is a Class A address. 8 to 191 is class B. 127 is missing. I'll write it here. That has got a different story to say. We'll come to that later. And for class C, it is 192 to 223. So when you see an address, the first number will tell you to which class that belongs to. Example for class A, 10, 1, 2, 3. Example for class B, 100, no. 190, yes. 194, 8, 10. Class C, 200.532. Now, in this examples, what all we learn, what all the information it conveys. When you see 10, you understand it is class A. It also conveys another message. What is that? This is the host ID, not the network. This 1.2.3 indicates that in the 10 network, inside the 10 network, there are many computers. The one with this 1013 device ID is 123. 123 is the device ID, host ID, interface ID of the network 10. Inside the 10, you may be having many computers. 10.1.2.4, that is another computer's ID. In the 10 network, 123 is one computer's ID, 124 is another computer ID. How do I know that? Because I know class A means only the first octet is network. The other 3 octets are host. That's the message that it conveys when I see 10. That is why the default mask for class A is 255.0.0.0. It means that 255 you will get only if you add all the 8 bits with 1. When you say 10 network, it means that the first octet is network. It is masked, meaning those 8 bits are not host bits. That's the meaning of this 255. These 8 bits are network bits. We call it as default subnet mask. You can also write like this /8. This 255.0.0.0 can be also written as /8. Both are same. Writing /8 is equal to 255.0.0.0. Class B is 255.255.0.0, which can also be written like /16. It means that /16 means that the first 2 octets are network. The other 2 octets are host. So 8.10 is the host ID. Inside the network 192.4. 194. 194 is the network. In that network, the host is identified with the number 8.10. Class C default mask is 255, 255, 255. Why? Because those three are network. And for the host, it is 0. So the mask can also be written like /24 because 24 bits are for network. Mask represents the number of bits that are given for network. Mask, subnet mask is nothing but number of bits that are given for network is told there. In the subnet mask, that's what it is told. It is telling us that in that above address, these two are network portion, these two are host portion when you see this mask. And by default, class B means this is the mask. When you do subnetting, the mask will be more than /16 for subnetted networks. We'll talk about that later. That is classless. When you do subnetting, you break the class behavior, class boundaries. That's later story. Now we have learned that IP address version 4 has got 32-bit. To avoid wastage, classification is done, and 3 classes for unicast. For unicast address, what is unicast? Unicast is casting to one particular device. When I say Paul, you got first rank, it means unicast. I'm talking to Paul. When I say 10th standard, it means a group, multicast. It's not for the entire school, but it is for a group of people in the school called 10th standard. That's multicast. Now, to talk to an individual device, particular device, we use unicast address. For that, we have 3 classes, A, B, and C. Class D is for multicasting. Class D is for multicast. Class D. Class D ranges from 224 it's ranging from 224 to 239. When you find an address beginning with 224 to 239, they are all multicast address. Not meant to be assigned to a computer. If you try giving an address starting with 224, it won't accept. Let me show you that. I'm going to try assigning IP address to one of my Ethernet interface. Lot of changes. No, I'll go to the control plane. Control panel. So see what happens when I try giving an IP address beginning with 223 and above. I'll just type that number. When I say 222, it's not complaining. 223, not complaining. 224, immediately it says, not a valid entry. Please specify any number between 1 to 223. Yeah, that's the unicast range. That's the range in class A, B, and C, isn't it? Class A starts with 1, class C ends with 223. Yeah. So we can't have any address in this range 224 to 239. They are meant for group, not for an individual device. When you come to CCNP, CCIE studies, you will talk about multicast again. Now, class D, you should know that this is the range and it's a multicast range. Let's go back to our classes A, B, and C now. The unicast range address. I want you to keep these range in mind. 1 to 126, class A. See, now it may sound easy to remember, but you have to remember for long so that when you see an address, you can get a clear picture about the network. When you don't know the ranges, you will be confused when you do subnetting. You will be confused when someone talks about subnetted network. You should know this number range. Class A, 1 to 126. B, 128 to 191. C, 192 to 223. How they derived this range, there is a big story behind that, but it's not so important. So better remember this range. Any questions so far?
No, sir.
Great. Now, what about 127 there? You might have already know. Any address that is beginning with 127 cannot be assigned to a computer because it is meant for a special purpose called loop back. See, for example, I'm trying to give an address starting with, when I say 126, it won't complain. But when I say 127, again it says something. It says IP address starting with 127 are not valid because they are reserved for loop back address. Alright, so please specify some other valid values between 1 to 223. So you can't use 1224 because it is multicast. You can't use 127 because it is loopback address. What is the purpose of this loopback address? 127, any address, it can be 127.001, it can be 127.111, it can be 127, say any number, 50.30.100 or 127 blah blah blah. What these 127? 127 can provide you lakhs of IP address. 2 to the power of 24 What's the value you get? A big number. 2 to the power of 24. You get a very big number actually. 1, 10, 100,000, 10,000 lakh, 10 lakh crore. Like 10 million, 16 million address you get. 1 crore 67,000. All are meant for only one purpose. What is that? Loop back. What is this loop back? Why they have given 16 million for this loop back? That is the mistake done. That's a mistake done. Only one address is enough for this loopback. But starting with any address starting with 127 is loopback it's a stupidity made in the beginning. Now cannot be changed because it is standardized. Now what is that loopback address? You go to your command prompt and try pinging 127, any number. I'm just randomly typing 56, 73, 76, 24 or 45, 43, whatever. But beginning with 127. Usually when you ping, you will ping a particular device address, correct? But who is holding this address? I'm getting a reply. I'm getting reply as if there is a computer with this address. Is there any computer? No. I tried giving 127, it didn't accept. Then who is responding? Who is that replying me? When my PC sent 4 packet, it receives a reply. Who is replying me? Who is holding this address? From where I am getting reply? Is it my router? Or is it my neighbor PC? Who is replying me? And why it is called as loop back address? We all know what is looping, rounding. Loop back means what? Coming back. Coming back. What it means? You are getting reply back. You send the request and it is coming back as a reply. But who is replying? Now I am just making another change. For instead of 43, I am saying 34. For that also someone is replying. Okay, I'll change the first octet. Instead of 56, I'll say 100. Then also someone is replying. Who is replying me? Is there anyone from outside? No. It is within the laptop via which I am teaching you. Someone is replying. My own laptop is replying to myself. That's why it is looping back. Loop back address. See, using this command prompt application, I generate the ICMP traffic by saying ping. What this operating system does is, it is sending the packet to the physical layer. And when everything is fine from the application layer down to the physical layer, the programmed operating system will reply saying your OSI 7 layers are working fine. OSI is good in your laptop. Your laptop is good to be connected to the network. See, when you don't get reply for your loopback, then you have some problem with the network driver or some physical layer issues. Mostly it will be layer 1, layer 2 issues. When the reply comes, it means your PC is eligible to be part of network. Your OSI layers are fine. That's the meaning. That's what this reply conveys. I hope you understood the purpose of loopback address. It's a self-diagnostic test. It's a self-diagnostic test to test your own PC. Do you have any question? All right. Now, there is another address which is not used. Meaning, there is another address which is also reserved for a special purpose. Like this 127 reserved for loopback, there is another address starting with 169.254. We just saw 127. As loopback. Likewise, in class B, see this is in between class A and B. This looks like class A only, so you can call it as class A. In that class A, this is a special address we cannot assign to a PC. It's meant for loopback. Likewise, in class B, why I'm calling it as class B? Because class B range is between 128 to 191. Address in between this range. That's why I say this belongs to class B, but it is meant for some special purpose. What is that special purpose? Whenever DHCP, Dynamic Host Configuration Protocol server, whenever a DHCP server failed to give IP address, these PCs will generate address. I repeat, these devices are DHCP client. They expect an address from a server, but the server is not giving. The reason may be the switch is off. So client and server is not able to communicate. Or this device is off. Or there will be a pool of address which is already given to other clients. There is no more address available in this. No more address available in the pool for the new clients. Any one may be the reason. Any one of this may be the reason. So what happened is these clients They waited for the server. After the wait time got over, this address is auto-generated so that the users in this machine, so that the people sitting on that machine trying to figure out the problem will be able to identify the problem. The problem is with the server. When you type ipconfig in the command line, command prompt, you will see this address when DHCP server failed to give you one address. Instead of getting a valid IP address, you're seeing 169.254. It's not a valid IP address. It is not from a DHCP server. It is the Windows or Linux or whatever, the Ubuntu or whatever the operating system that you are running in the device generated address. It is generating this address to convey you a message that server is not giving address. You ask me to get it from the server, but the DHCP server is not giving. That's the message 169.254 conveys. And this address is auto-generated, I told you. That's why the name for this reservation is called as APIPA, Automatic Private Internet Protocol Address. Automatically it is generated, and definitely it cannot be used for communicating to Yahoo and Facebook. So it is private, and it is Internet Protocol. Correct? No, it's an IP address. So Internet Protocol address, IPA, APIPA. 169.254 extra text is APIPA address. It is meant to inform the users that the server has failed to give address. Okay, the server has failed to give an address. APIPA address. Any question on APIPA?
No, sir.
Right.
No, sir.
Now, let's get into subnetting topic. Subnetting. It's not understanding my writing. I don't want this. I was trying something which I don't want to erase. Okay. Now, trying to understand that 8-bit. I told you, in an address there are 4 sets of 8-bit. 4 sets of 8-bit. 8-bit dot 8-bit dot 8-bit dot 8-bit. This is how the IP address is. What's going on? I don't want these things. Good. All right, so 8-bit dot 8-bit dot 8-bit dot 8-bit is what IP address is. So we are going to try understanding one 8-bit, one octet. That will be the story for all other octets. 1, 2, 3, 4, 5, 6, 7, 8 bits you have. and it is binary. Binary number system is using only these two numbers to form the entire number system. See, in decimal, you have 0, 1, 2, 3, 4, 9. Totally how many numbers? 10 numbers are there, 0 to 9. If you count and see, there are 10 numbers. That's why we call this decimal, deca, 10, decimal. The number system that we use in day-to-day life is decimal. It's not binary. This is the reason why we write IP address in decimal form, isn't it? We use IP address, we write IP address in decimal form. You see 169.254, 192.4. This is the number that we use day-to-day life. We don't write IP address in binary. But originally, the IP address is in binary. What does that mean? For that, you should know what is decimal proper. In decimal, you have only 9 numbers. You may say, no. What about 2025? Is this not a number? No. It's not a fresh number. This 2 you have written here. This 0 you have written here. Again you return 2 here and this 5 here. You made this address, you made this number out of this 9, 10 numbers. Just by using this 10 number, we make big numbers. But originally it is from this 0 to 9. This 2025 is not a fresh number. Likewise. In binary, these are the two fresh numbers. 0 means 0, 1 means 1. In binary, 0 means 0, 1 means 1. How do you write 2? Put that 1 here and 0 here. That is called as 2. How do you write 3? This means 1 and this means 2. So 2 plus 1 is 3. How do you write 4? Put 1 here and put 2 zeros. That makes 4. And how do you write 5? 4 plus this number 1. 5, 1, 0, 1. This is 5. So these are all not fresh numbers. These are all made out of just these two numbers. That is why binary, just two number. Because it is only two number which makes other numbers, you put 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Whereas for decimal you don't put 2 to the, for example 2025. Do you put 2 to the power of 0, 2 to the power of 1 in the 6th standard? Did they teach you like this? No. How did they teach you in 6th standard? They taught you like this. 10 to the 5 into 10 to the power of 0. 2 into 10 to the power of 1. This is how they taught you. Why 10? Because this number is made out of this decimal. 2 multiplied by 10 to the power of 0. 2 multiplied by 10 to the power of 3. What is the value you get? 10 to the power of 0 is 1. Anything power 0 is 1. 1 multiplied by 5 is 5. This is 10 to the power of 1 is 10. 10 multiplied by 2 is 20. And 10 to the power of 2 is 100. 100 multiplied by 0 is 0 only. And this is 1000 multiplied by 2, 2000. Now you add and see, you will get 2025. Why put you 10? Because it is decimal. I cannot put 10 for IP address because IP address originally it is binary. So I put 2 to the power of 0. Binary will be either 0 or 1. Let's see an example with all ones. Anything power 0 is 1. 1 multiplied by 1 is what? 1 only. 2 to the power of 1 is 2. 2 multiplied by 1 is 2. 2 to the power of 2 is 4. Isn't it? 4. 4 multiplied by 1 is 4. 2 to the power of 3 is 2 into 2 into 2, which is 8. 8 multiplied by 1 is 8. 2 to the power of 4 is 16. 2 into 2 into 2 into 2 is 16. 16 multiplied by 1 is 16. 2 to the power of 5 is 32. 32 multiplied by 1 is 32. 2 to the power of 6 is 64. 64 multiplied by 1 is 64. 2 to the power of 7 is 128. 128 multiplied by 1 is 120. So these are all the values. We call it as phase values. The place values. What does that mean? Place value. If 1 is in this bit, it means 32. If 1 is in this place, it means 4. For example, if I have 0, 0, 0, 0, 1, 1, 1, 1, what does that mean? It means 15. How? Because this place value is 8, this place value is 4, this place value is 2, this place value is 1. When I add these, I get 15. Decimal. I converted binary to decimal. How easy it is? Did you understand?
Yes, sir.
Okay. I'm going to give you exercise now. You're going to quickly convert and tell me. Alright? Are you ready with a pen and paper? 1,0,0,0,0,0,0. What do you get? What's the total value? Answer, anyone?
128, sir.
That's it. 128 because all the rest are 0. Okay. Now 1,0,0,0,1,1,1. What do you get?
135.
Exactly. 135. Because this is 1, this is 2, this is 4, which gives you 7. Plus this one is 128. And you get 137, 135. It's not 137. I made it wrong. You said correct. I wrote 7. But actually I mean 5. So 128 plus 7 is 135. Very correct. I don't know who answered. What about the other person? Do you agree with us?
Yes, sir.
Oh, great.
Correct.
Let's do it. Let's do another one. 1, 1, 0, 0, 0, 0, 0, 0.
$192.
Exactly. 192. 128 plus 64. Great. Let us do the other way around now. I want to write 10. For that, what I do is 0, 0, 0, 0, 8 plus 2. I write like this. Do you agree? See, this place value is 8,
Yes,
this
sir.
place value is 2. Now you need to write like this and let me know, okay? So I'm going to give you the number. Are you ready?
Yes, sir.
224.
One one zero. 1110. The rest all zeros. Four
Super.
zeros.
Very correct. So 128 plus 64 plus 32 is 224. Right. Next. Okay. That's a good job. Um, 72.
0100.
0, 1,
1000.
0, 0, 1, 0, 0, 0. So,
000.
which means 64 plus 8. Correct. Is 72. 64 plus 8 is 72. Very correct. Shall we go another one?
Yes, sir.
Okay. 15.
0000. 1111.
Okay. What about the other person? Other person is not talking. I'll give you another one.
I'm
Try.
following.
You're following, right? You're not feeling difficult, right?
Yeah, I'm following.
If you're
No,
feeling
no.
difficult, you should ask. That is what actually what I want. Okay. So 195.
Uh, 11000011.
Exactly. Super. This is 192. We already saw here. Plus 2 plus 1, 3. 195. Great. So with this, we will enter into subnetting. You need this knowledge, very important for subnetting. You should know these things, how to calculate. Subnetting is like borrowing some bits, so you should know the value of borrowed bits. For that, I have given you this exercise. We'll